Assalamu alaikum, my dear students. Hopefully you are well and safe. Welcome to Higher Mathematics online class. This is Imam Hasan, Senior Teacher, Department of Mathematics, Milestone College. Today we discuss Chapter 6, CONICS. This is our 5th lecture from this chapter. In this class we discuss two important math, example 4 and example 5 from exercise 6C. Hopefully, you all will be attentively participate to today's class. So, let's start our class. My dear students, today we discuss chapter 6 CONICS. Today we discuss two important math from exercise 6C. At first we discuss example 4. Here, example 4, find the equation of such hyperbola whose focus is 1, minus 8, eccentricity is square root 5 and the equation of directrix is 3x minus 4y equal to 10. So we have to find the equation of hyperbola using the given information. So let's try to solve this problem. Here, given that focus is 1, minus 8. So focus, we denoted focus as S, whose coordinate is 1, minus 8. In the figure, this is the focus S, whose coordinate is 1, minus 8. Here, eccentricity is square root 5. So, eccentricity E equal to square root 5. And the equation of directrix 3x minus 4y equal to 10. We can write this one as 3x minus 4y minus 10 equal to 0. We denoted this equation as equation number 1. So in the figure, this is the directrix, that is 3x minus 4y minus 10 equal to 0. Now we have to find the equation of the hyperbola. Now let P be any point on the hyperbola. Let this is a point P on the hyperbola whose coordinate is x, y. So now we have to write let P, whose coordinate is x, y, be any point on the hyperbola. Now, by the definition of hyperbola, we know that SP equal to E into PM. By the definition of hyperbola, SP equal to E into PM, where SP is the distance between the point P and the focus point S. So PS is this one, equal to E, where E is the eccentricity whose value is square root 5, and PM is the perpendicular distance from the point P to the directrix. Let this is the perpendicular distance PM on the directrix MZ. So by the definition of hyperbola, we know that SP equal to eccentricity into PM, or SP, here the coordinate of the point P is x, y and the point S is 1, minus 8. So SP equal to square root x minus 1 whole square plus y minus 8, that is plus 8 whole square, equal to E. Here the value of eccentricity is square root 5 into PM. PM is the perpendicular distance on the directrix 3x minus 4y minus 10 equal to 0. So putting the coordinate of the point P on this equation, we will get 3x minus 4y minus 10. So the perpendicular distance will be modulus this one divided by square root Here coefficient of x is 3, so 3 square plus coefficient of y is -4, so -4 whole square. Now solving this equation, we'll get the required equation of hyperbola. Now for solving this equation, at first we have to remove the square root sign. For removing a square root sign, we have to square on both sides. So by squaring on both sides, we'll get here x minus 1 whole square plus y plus 8 whole square equal to square root 5 whole square equal to 5. 3x, here modulus 3x minus 4y minus 10 whole square, it will be 3x minus 4y minus 10 whole square. At denominator, square root 3 square plus minus 4 whole square. By squaring this one, we'll get here 3 square equal to 9 plus minus 4 square equal to 16. So 9 plus 16 equal to 25. We have to write the side note by squaring. Here dividing the numerator and denominator by 5, we'll get here 5. Now, or x minus 1 whole square, we can write this as x square minus 2x plus 1 plus y plus 8 whole square. So y square plus 16y plus 64 equal to here 3x minus 4y minus 10 whole square divided by 5. Now here 5 becomes multiply 5 x square minus 2x, here 1 plus 64, it will be 65 plus y square plus 16y equal to here 3x minus 4y minus 10 whole square. By using a plus b plus c whole square, this formula will get a plus b plus c whole square equal to a square plus b square plus c square plus 2 into a into b plus 2 into b into c plus 2 into c into a. Then here 5 into x square, that is 5x square. Now 5 into minus 2x equal to minus 10x. Then 5 into 65 equal to 325 plus 5y square. 5 into 16 equal to 80y equal to here 3x whole square equal to 9x square plus minus 4y whole square equal to 16y square minus 10 whole square equal to plus 100. Here plus minus makes minus, 2 into 3 equal to 6, 6 into 4 equal to 24xy. Here minus minus makes plus, 10 into 4 equal to 40, 40 into 2 equal to 80y. And finally plus minus makes minus, 2 into 10 equal to 20, 20 into 3 equal to 60x. Then from the right hand side we can write here 9x square plus 16y square plus 100 minus 24xy plus 80y minus 60x. Now taking all the terms from the left hand side to right hand side, we will get here 5x square becomes minus 5x square, then plus 10x, then minus 325 minus 5y square plus 80y becomes minus 80y equal to 0. After calculation, finally we get here 9x square minus 5x square equal to 4x square. 16y square minus 5y square equal to plus 11y square. Minus 24xy, then minus 60x plus 10x equal to minus 50x. Here minus 80y and plus 80y will be cancelled. Finally, plus 100 minus 325, it will be minus 225 equal to 0, and this is the required equation of hyperbola. So we have to write it is the required equation of hyperbola. My dear students, hopefully you will understand this math. My dear students, now we solve example 5. Here example 5, find the coordinates of two foci and equations of two directories of the hyperbola x square by 9 minus y square by 16 equal to 1. So we have to find the coordinates of two foci and the equations of two directories of the given hyperbola. So let's try to solve this problem. At first we write here the given hyperbola, the equation of the hyperbola. Here the given equation is x square by 9 minus y square by 16 equal to 1. We denoted this equation as equation number 1. Now comparing the given equation 1 with the standard form of hyperbola x square by a square minus y square by b square equal to 1. Then we get here a square equal to 9 and b square equal to 16. So we can write a equal to 3 and b equal to 4. So by comparing the given hyperbola with the standard form of hyperbola, we get a equal to 3 and b equal to 4. Now we have to find the coordinates of the two foci. For finding the coordinates, at first we have to find the value of eccentricity. Here the eccentricity of the given hyperbola will be e equal to a square root 1 plus b square by a square. So we have to write, we know the eccentricity of hyperbola e equal to a square root 1 plus b square by a square. Now putting the value of a and b, we will get 1 plus, here already we get b square equal to 16 and a square equal to 9. Then by simple calculation we will get 25 by 9, that is 5 by 3. Here a square root 25 by 9 equal to 5 by 3. So the eccentricity of the given hyperbola e equal to 5 by 3. Now we have to find the coordinates of the foci. So we have to write, therefore the coordinates of two foci, we know the coordinates of two foci of the hyperbola is plus minus ae comma 0. Therefore we can write plus minus a, the value of a is 3 into e, the value of eccentricity e is 5 by 3 comma 0. Therefore we will get plus minus 5 comma 0. So this is the coordinates of two foci of the given hyperbola. Now we have to find the equation of two directories of the hyperbola. Therefore the equations of two directories x equal to plus minus a by e, or we can write x equal to plus minus a. Here the value of a is 3 and the value of eccentricity e is 5 by 3, or x equal to plus minus 9 by 5. So we can write 5x plus minus 9 equal to 0, and this is the equation of two directories. So this is our another answer. So my dear students, hopefully you are understand this math.